there a better way to solve inequalities? I don't think so. We're going to finish up our last section of the review chapter on linear, compound, and absolute value inequalities. There are a lot of different kinds of problems here, so we'll take them one at a time. I wrote down 52 inches tall right here because I remember taking my grandson to the carnival. And some of the rides that he wanted to ride on, you had to be at least 52 inches tall. And for a while he couldn't ride on them because he was under 52 inches, but eventually his height became greater than or equal to 52 inches. An example of an inequality. A linear inequality is any relationship of the form ax plus b is greater than 0, ax plus b is greater than or equal to 0, ax plus b is less than 0, or ax plus b is less than or equal to 0. This is the first type of inequality that we will solve. So I have three sets here, and I want to consider three statements, and I want to consider the solution sets for all three of these. The first one is not an inequality, it's an equation, and if I subtract 2 from both sides, I'm going to get x equals negative 2. Notice a single number in the solution set. But here, if I subtract 2 from both sides, kind of like I did here, I would end up with x is greater than or equal to negative 2. Now there are a lot of numbers that are greater than or equal to negative 2. With these inequalities, you're going to have solution sets that are going to have infinitely many solutions. So we're not going to be able to write them one at a time like I did with an equation. We're going to have to write them out either using set builder notation or interval notation. And in some of the problems, they'll ask for both. The set builder notation uses the braces, and it's the set of all x such that x is greater than or equal to negative 2. Now when I was a student in school, my teacher would make us also write down comma, x is an element of the set of real numbers. Oops, let's make that a brace. There we go. This textbook that we're using doesn't require this part, although it's good practice. Now, interval notation I think is far superior here. We want all the numbers from negative 2 greater, so we've talked about this before. We're going to use a bracket here to include the negative 2, and to show that it's greater than, we use the infinity symbol. Remember, no bracket next to the infinity symbol, it doesn't stop. In this example here, if I subtract 2 from both sides, another linear inequality, I get x is less than negative 2. Now x is less than negative 2 also has infinitely many solutions, so set builder notation time. I would have the set of all x such that, this line like that means such that x is less than negative 2, and of course x is an element of the set of real numbers. But in interval notation, we want all the numbers smaller than negative 2 but not including the negative 2. There's no equal sign here. So I went from negative infinity to negative 2, but this time, remember, to use a parenthesis. The properties that we use to solve linear inequalities, in fact all types of inequalities, are very similar to the properties that we use to solve equations. In that we can add the same number to both sides, and we can subtract the same number from both sides. I have only examples of this written out with the greater than sign here, and you'll see that there are two keys with little asterisks next to them that we want to emphasize. But the addition property of inequality says essentially that if a is greater than b, then a plus c is greater than b plus c, for a, b, and c being real numbers. And the subtraction property of inequality says that if a is greater than b, then we can subtract the same number, a minus c is greater than b minus c. Now, for multiplying and dividing, we have to break this into cases. If a is greater than b and c is positive, so we're going to multiply by a positive number on both sides. Notice it's a greater than, it's a greater than. A times c is greater than b times c, as long as c is positive and a is greater than b to begin with. But notice, if a is greater than b and c is negative, if I multiply both sides by a negative, we know that a positive times a negative is negative, a negative times a negative is positive, so things get switched around. A greater than b and c less than 0 implies that a times c is going to be smaller than b times c. Real quick, if I have 3 is greater than negative 1, and I multiply both sides by negative 2. Negative 2 times that, negative 2 times that. See how the inequality sign reverses? It reverses its order. So, or you just kind of flip the sign around, but we call that reversing the order. Here, when we multiply by a positive, we keep the same order. When we multiply by a negative, we reverse the order. And very similarly with division, because division is just multiplying by the reciprocal. If A is greater than B and C is positive, not 0, C is positive, then A times C is greater than B times C. But if C is negative, A times C is less than B times C. So you have the addition property of inequalities, subtraction property of inequalities, multiplication properties of inequalities, and division properties of inequalities. And we use those when we are isolating our variable, as I'm going to show you here in the next couple of examples. It says solve the inequality, graph the solution set, and then write the solution set in both set builder notation and interval notation. Well, the first one is pretty straightforward, no fractions. I'm going to go ahead and I'm going to add 6 to both sides. That's the addition property of inequality. And that gives me negative 5t is greater than or equal to 30, and then I'm going to divide by negative 5. Now here's a good reason why you write this as a separate step. You don't just leave this step as is and put division or fraction bars underneath to write the negative 5s below, because we are going to reverse the order. We're dividing both sides by a negative, and I have t is less than or equal to 30 divided by negative 5, which is negative 6. So in set builder notation, this would be the set of all t such that t is less than or equal to negative 6 and t is an element of the real numbers. But in interval notation, we have t is less than or equal to negative 6. That's going to look like negative infinity, negative 6 with a bracket. It also asks for the graph. We graph these on the number line. So I'll put it over here. And this is not a very good number line here. And I'll just put a few points. My key value that I'm looking for is negative 6. You don't have to make this extra big. But I want all values that are going to be less than or equal to negative 6. I want to include the negative 6. Now in the old days we'd have a filled in dot. Now we use a bracket. And we want all the numbers less than, so we shade with an arrow to the left. This next one looks a little bit more intriguing, and we have to be careful with our signs. But the first thing we're going to need to do is we're going to need to get through this by getting rid of the fractions, and the least common denominator is 10. So I'm going to multiply both sides by 10, and since it's a positive 10, that does not reverse the order. So 10 times the left side, and 10 times the right side. Over here, this is like 10 over 1. I distribute. 2 goes in that once, 2 goes in that 5 times. So that'd be 5 times m minus 4 minus. Now I multiply the 10 times over here. The 10s we're going to cancel. And that leaves the quantity m, 3m plus 4, which I put in parentheses because of the subtraction sign right here. The 3m plus 4 has a subtraction sign. I have to subtract all of it. On the right side, 5 goes in that once, goes into that twice, so I have 2 times negative 3m is negative 6m. I have to get rid of those parentheses, just like with a linear equation. We want to simplify both sides, eliminate parentheses, combine like terms. 5m minus 20, this is like a negative 1 that we distribute by, minus 3m minus 4 is greater than negative 6m. Alright, I'm going to combine like terms. That's 2m minus 24 is greater than negative 6m. Now I'm a guy that kind of likes to have a positive coefficient in front of my variable for inequalities. So I'm going to do an extra step that you may want to skip, but what I'm going to do is I'm going to get the variable on the left side, because I already have a positive here and a negative here. I'm going to add 6m to both sides, and in the same step, I'm going to get rid of the minus 24, I'm going to add 24 to both sides. So 2m minus 24 plus 6m plus 24 is greater than negative 6m plus 24. Kind of did doubled up there. The 2m and the 6m are is equal to 8m. Those cancel. Is greater than 24. If you were to subtract 2m from both sides, then you're going to end up with a negative 8m on the right, and then you're going to have to divide by a negative 8, and you're going to have to reverse the order. And I mean, you probably won't forget to reverse the order, but it's just one extra step that you might make a silly mistake on. I'm going to finish this off by dividing both sides by 8, a positive number. And I have m is greater than 3. So that's my answer. I'm going to write it in set builder notation and interval notation. See if I can sneak the graph in here. Didn't give myself very much space. My key value is 3, so 3 right there. I'm going to, let's see, do this with a brown pen here. I want all values greater than 3, so, but not including the 3, so a parenthesis opening to the side where I'm shading. There's my graph. And in set builder notation, the set of all m such that m is greater than 3 and m is an element of the real numbers. And in interval notation, it would be parenthesis 3, comma, infinity. And I have all 3 parts of my solution.